In this problem, we'll determine the oxidation states and the number of d electrons in the metal atom in each of 5 different coordination complexes, beginning with this ruthenium complex. Each chlorine is at an oxidation state of -1 for -2 in total. The ammonia is neutral, and since the complex is neutral, the ruthenium ion must be at a 2+ oxidation state. Ruthenium is in group number 8 of the periodic table, and so the neutral atom would be S2D6. To make the Ru2+ requires removing those 2 s electrons, and thus there are 6 d electrons in the ruthenium 2+ ion and in this complex. The name, by the way, of this complex is hexaamine ruthenium 2 chloride. How about this chromium complex? There are 3 iodines in it for a total of -3. Each one is at -1. The ethylene diamine is neutral, and therefore the chromium must be at a +3 oxidation state because the complex is neutral. Chromium is in column number 6 of the periodic table, and so the neutral chromium atom would be S2D4. To make the 3+ ion requires removing both s electrons and one of the d electrons, and thus there are 3 d electrons in the chromium atom in this complex. And the proper name for this is trans-bis ethylene diamine diiodochromium 3 iodide. In this palladium complex, we have 2 chlorine atoms, each at an oxidation state of -1, so -2 in total. Each trimethylphosphine is neutral, and so the palladium must have an oxidation state of +2. Palladium is in column 10 of the periodic table, so the neutral palladium atom would be S2D8. To make the palladium 2+ ion requires removing those 2 s electrons, and therefore that leaves a D8 configuration in a palladium 2+ ion. The proper name for this compound is cis-dichlorobis trimethylphosphine palladium 2. Here's an iridium complex. We see 3 chlorides, -1 each, for a total of -3. The ammonias are neutral. The overall complex is neutral, so the iridium must be in a 3+ oxidation state. Iridium is in group 9 of the periodic table, so the neutral iridium atom would be S2D7, and to make iridium 3+ requires removing both s electrons and one of the d electrons, leaving behind 6 d electrons. And the name of this compound is FAC triamine trichloroiridium 3. And finally, we'll look at this nickel complex. The carbon monoxide is neutral, the overall complex is neutral, so the nickel atom must also be neutral, and nickel is in column 10, and the configuration is S2D8, so there are 8 d electrons in the nickel. This is called tetracarbonyl nickel 0.